guys, I'm happy to announce Global Framework, which consists of 3 parts: the module, the plugin, and a library of scripts. The first thing I'd like to say is that this framework does not interfere with your style of programming. So if you enjoy functional programming, object-oriented programming, or even things like data-oriented design, this framework does not dictate your style of programming. Essentially, the framework allows us to do 2 things, and that is to create global types and to create global variables. So the fastest way to see what it looks like to work with this framework is to download the library of scripts from the toolbox. I'm also going to provide links in the description to everything I show in this video. So let's go to the toolbox, and under models, I'm going to search for global library. And over here, you'll see from 5UP-HI is a model called global library. I'm going to click on this model. I'm going to press OK and close the toolbox. And now we should see that this model consists of a module script, and it consists of folders of many scripts. Now at this time we only have these scripts, but these scripts may grow and change as time goes on. But at the time of making this video, these are all the scripts that are currently provided. Let's now take a look at some of these scripts just to see what the framework looks like. So if we open the event script, the first thing we'll notice is that this script is in strict mode. So the framework does work correctly in strict mode. Then we can see that we create 2 types, but these types are in block comments. Now this indicates to the plugin that we want to make these 2 types a global type. Then we can see that we're requiring script parent, which is parent, this module script over here, and we've named this variable global. And then down here, we can see that we're calling this variable global like a function, and we pass in a index and a value that we want to make global. In this case, we're creating a global function. So that is essentially the 2 main concepts of this framework: the ability to create global types and the ability to create global variables. Now you may also notice that we have some other helper functions here, one called metatable and one called export, but these functions are not mandatory to use, and you can modify, remove, or add your own functions, and I'll be showing you how to do that later on in the video. But for now, I'm just going to say that this metatable function is essentially syntax sugar, just to make it more prettier, to make a metatable, and this export function is used for inheritance. We should also see that autocomplete works correctly with this framework. So if I come down here to the connect function and type in self dot, we can see we get all the values that we've defined within our event type. And if I use connection and dot, we can see we get these 2 properties that we find in our connection type. If we now open the timer script, and if I move this to the side, we should see that this timer script inherits from the event script. So we can see this event value that we exported is being inherited over here, and it's been inherited onto this timer metatable. And then we're using the clone method of inheritance. There's 2 modes, the clone mode and metatable mode. I'll be going over these 2 modes later on in the video. And we're inheriting the connect function, which is this function here, the once function, which is this function here, and the wait function, which is this function over here. Now, a feature of this inherit function is that the order of these scripts does not affect the inheritance. For instance, let's say we had a 3rd script that inherited from the timer script. What would happen is, first, it would ensure that the timer script inherited from the event script first. And then, once the timer script has finished inheriting, then it would allow our script to inherit from timer. So the order will be the correct order, even though these scripts run in a random order. Now that we've had a quick peek at how the framework looks, let's now close these scripts, and I'm going to disable all these scripts by setting enabled to false so they don't run. and I'm going to move this into server storage. Let's now take a look at the global module and the global types plugin. So the global module, we have two ways to get access to this module. One way is to download the library from the toolbox, or another way is to allow the plugin to generate the module for us. So the first thing we need to do is install the global types plugin. So inside of the toolbox, under plugins, you want to search for global types, and you want to install this plugin from 5UPHI. And once you've installed this plugin, you need to make sure you give this plugin permission to inject scripts. Now, once this plugin has been installed, you won't notice anything different about Studio. There won't be no buttons under Plugins tab, and there won't be no indication that this plugin is there other than it being inside of your plugin manager. Now that the plugin has been installed, the first thing we want to do is make a module script. We can place this module script anywhere we wish, and I'm going to name this module script global, but you can name it anything you like. But one thing we must do that's very important for the plugin to work, we must give this module a attribute, and we need to call this attribute global types with a capital G and capital T, and it has to be a Boolean type, and we have to press save, and we need to make sure we tick this on so the plugin knows that we're giving it permission to modify this module script. That's all we need to do for the module script. The next part is we now need to require this module script. Now we can place a script anywhere we want. We can place one in workspace, we can place it over here, we can place it over here, but I'm going to place it inside of the module. It's just personal preference. So I'm going to create a script, and I'm going to move the script in front so that we can see the module being updated in the background. And all we need to do is require this module. So I'm going to say local global equals require script.parent. Now we have the option of either creating a global type or a global variable. So let's first create a global type. We can create this type at the bottom or at the top of the script. It doesn't really matter. I like placing it at the top of the script. Another thing I'm going to do is I'm going to change this into a strict script. Now this is not mandatory, but I'm going to make it strict just to show that it works correctly. And to create a type, we just do it like the normal way. So we say type, and then we give the type a name, my global type, and then we can set this type to anything we wish. I'm just going to set it to a number type. Now, in order for this to be a global type, we must make this a block comment. So to make a block comment, you do 2 dashes, 2 open brackets, and then 2 close brackets. And once we've made this global type, we notice that the module behind updated. So if we scroll up and down, we can see that we have this deferred function over here. We can see we have the functions for initialize, start, export, and inheritance, and metatable. And at the top, we have our global type that we created over here, which is exported. My global type equals number. One thing we need to know about this plugin is the plugin is searching for local globals, and then once it finds these 2 words, it's going to search for this bracket over here on its own. And what it's going to do is anything above this bracket is going to be replaced. Anything below this bracket will not be replaced. So if I change anything below this bracket, for instance, if I add a print here, then this print will not be removed by the plugin. But if I place this print above this bracket, then this is going to be replaced by the plugin. So if I change this to my type A, we can see the plugin updated the script and the print went away. But if I have a print down here below the bracket, and if I make a change to B, we can see that this print never got removed. This is great because it allows us to modify the framework to work the way we want it to work. But the downside is if the plugin ever has an update that creates new functions that are slightly different or fixes any bugs in this code, then it's not going to update your module automatically. you're going to continue having the old version of the module unless you change these two words here. The plugin is looking for local globals. So if I just remove the S from this local globals, now the plugin won't be able to find this local globals, and it's going to cause the entire module to be replaced. So if I make another change now that we've removed the S from globals, this print over here is going to get removed because the entire module is going to update. So let's remove the B, and we can see that my print went away. Because this module is quite long, every time it gets updated, it scrolls down to the bottom, and it's kind of hard for me to demonstrate what the plugin is doing while it's scrolling down. So what I'm going to do is I'm just going to quickly delete some of these functions, and I'm also going to delete this defer. And this is only so that the module no longer scrolls down. So every time I make a change, we can see that the change takes effect. Also, as a side note, if you find it annoying having to create block comments all the time, I've created another plugin called Toggle Block Comments. And what this plugin does, it gives you a keyboard shortcut to toggle the block comments. So once you've installed the plugin, inside of Advanced, Customize Shortcuts, if you search for comment, you'll see that there is a new command called Toggle Block Comment. You can set any keyboard shortcut you like. I've set it to Control and question mark. And now if I press Control and question mark, we can see I can remove the block comment. And if I press it again, it brings the comment back. So I can quickly add and remove global types. Now that we know how to add a global type, let's add a global variable. So if we look over here, we can see there's a function that gets called when we call this value over here. So down here, I'm going to say global, and I'm going to call it like a function. Now the first thing it needs is a index value. Now this can be any value we want. I'm just going to call it, make it a string, call it my index. And then it wants a value. Now if we pass in no value, over here we can see it says if value is equal to nil, then set value as a table. So if we wanted to create a table, we can just leave it as nil. But if we want to pass in another value, we can pass in our own custom value. So for now, I'm just going to pass in the value of a number, which is 1, 2, 3, and 4. Another thing we can see is that whatever value we pass into the function gets returned back to us. So if I wanted to store this 1, 2, 3, 4 locally, I could create a local variable, and I'm going to call it my number equals. So this value that we pass into it gets returned back and stored into this variable over here as well. Now currently, even though we're adding this into the globals table, and if we ran the game, we would see it inside of this table, we still don't have type check-in. So if I type in global with a dot, we can see we have the start and index functions, which are these two functions here, but we don't see this my index that we've added into the global table. If we want my index to show up in autocomplete, what we're going to need to do is tell the plugin what type this value that we've passed into the function is. So over here, all we need to do is cast a type onto this function. So I'm going to cast it as a number. And now we can see that the plugin added this into the module. So now if I try to press dot for global, we can see that my index shows up, and it also says it's a number. If I change this to a string, we can see that the plugin updates the module to say it's a string. And now we can see that my index is a string. It's also possible to cast a global type over here as well. So what I can do is say global dot, and we can see my global type A, which we created up here, shows up. And if I set it to this type, we can see that here it says global dot my global type A, but over here the global dot was removed and it only points to my global type, which is correct because it can point directly without having to use this global dot. And now if I press dot, go over here, we can see it's a number because this is a number. If I change this to a string and press dot, we can now see it says string. let's now remove this and let's change this back to a number. And let me move this script to the side and let me duplicate this script. And let's move this over here. And then let me name this script script A and this script B. The first thing we're going to notice is that we now have some warnings. Now we have a warning over here inside of the module, and this is a standard Roblox warning. So if we mouse over, we can see it says my global type A was previously defined on line 2, which is over here. Now this is a standard warning, but over here we can see some warnings generated by the plugin. And we also have warnings over here on script A, but because we haven't analyzed this script since we duplicated script B, so if I make a quick change on script A, it should reanalyze this script, and now the plugin gives us warnings over here as well. So if I mouse over type, we can see it says previously defined my global type A in server script service global script B at line 3. So if we look at script B on line 3, we have defined this same type over here. And if we mouse over this type, we can see that this points to script A. So this is saying that we've already used this global type before, so we have a conflict. We need to make sure we use a different global type name. So I'm going to change this to B, and that should cause the warning to go away. Now we still have a warning in script A because this script hasn't been analyzed yet. So we can make a quick change. It's going to analyze and the warning will go away. While we've resolved the conflict for our global types, we have not resolved the conflict for our global value. So if I mouse over this global warning, we can see that it says previously defined my index in server script service global script A. And over here, we can see it points to script B. So what we need to do is make sure that the index we use is different for these two values. So I'm going to call this my index B and this one my index A. And now we can see the warnings went away. Another thing you need to know about the plugin is the plugin doesn't really care if you place this cast outside of this bracket or inside of this bracket. Now, why would you want to put this cast inside of the bracket? Let's say we didn't want to store this number locally and we only wanted to add a value into the global like so. Now we can see that Roblox starts to complain about this because it doesn't really understand why we're casting this function into this type. So what we can do is move this cast to go inside of this bracket and the plugin will still be able to detect it. And now Roblox no longer complains. So in short, if you're creating a local variable like this, you want to put the cast on the outside of the bracket. If you're not creating this local variable, then you want to put the cast inside of the bracket. Okay, so instead of just having a basic number type, let's change this to a table type, like so. And now what I'm going to do is I'm going to set this to this type. So I'm going to change this to my global type A. And it's going to complain because this is a table, but this is a number. But what I'm going to do is I'm going to move this outside and I'm going to say local my table equals. Now we can see the complaint goes away because it doesn't really know what this function is. It thinks it's any, so it's allowing us to cast it into a table. But I'm not going to pass in a number. I want the function to create the table for us over here. And now if I press my table dot, we currently have no autocomplete, but if I add a value like so, and if I set this to a number type like so, now I can press dot and we can see I get value. It should work from script A as well. So if I go to script A and over here, if I type global dot, we should see the two indexes that we inserted into the global. If I go to index B, then dot, we can also see this value type we created over here. And we can see it's a number. So if I did a index B dot value equals string, we can see we get a warning. But if I try to set it to a number, the warning goes away. It's also possible for this type to reference this type. So for instance, over here, I could say type A is equal to my global type A, like so. And now we can see that this points to this. So if I go over here and press dot, we can see type A is equal to a number type. But if I change type A to be a string, now type A is equal to a string. So we can reference another type from another script like so. There's also no problem with having circular type dependencies. So for instance, I can change this to a table and I can add the value of type B and set it to the same type as type B over here. And now I can see I have type A, which is a global type A. And then inside of here, we have type B, which is a global type B. And in here, we have a type A. So here we can see a circular type. Another feature the plugin provides is the ability to use the script's name inside of your type. So over here, instead of saying type B, I could place a hashtag and the plugin is going to change this hashtag into the script's name. So over here, we can see it used script B, which was this name over here. Now, if I change this to ABC and then update this script so it's reanalyzed, we can see it now has the ABC just like the script name. And if I want to change this back, change it like this, reanalyze, and now it's like so. We can also use it down here. So if I wanted, I could put a hashtag over here, like so. And now we can see over here, it says script B. One downside is this part over here cannot be automated to use the script's name. So we must use the autocomplete to select the correct type, script B. Now this part over here can be automated to use the script's name. So for instance, I could place a ... script.name, and we can see that the plugin was able to work out that this is my index B script B. Let's change this back to how it was before. So I'm going to Control Z back to its original style. And let's also delete this. Another feature the plugin provides is variable name guessing. So what that means is over here, we say script.parent to point to this module script. And the plugin is able to work out that this is pointing to this module script. But let's say we made a variable equals, and let's say we did game, and we said get service, and we got the server script service. And let's say we passed v.global. So now we're pointing to this global module, but the plugin is not going to be able to work out that this v variable is equal to server script service. But if you name the variable the same as this string over here, then the plugin is going to be able to decipher that the variable equals to this service. So if I change v into server script service and set this over here, now we should see that index B came back. If I name this something else, we can see that index B goes away. So as long as your variable name matches the service name, the plugin will be able to work it out, and it's not case sensitive. So if I used a lowercase s here, the plugin will still work correctly. The plugin doesn't really care what this variable is, it only cares about the name. So for instance, I could just change this to use script find first ancestor, and I could use the server script service to find it like so, and this will work the same. Or if I wanted to, I could just say directly inside of here, I could say game dot server script service global, and this should also work as well. Let me now show you how to create meta table types. Now normally in Roblox, to create a meta table type, we create our type equals, and we have to use type off, and then we can say set meta table table, and then we would cast these tables to be the type that we want, like so. And then we would place anything inside of here. So we might have a value that is a number, And inside of the meta table, we may have underscore underscore index, which is equal to maybe another table. Using this type as a global type is no problem. So if we just wrap this in a block comment, we can see that this type gets copied over and there's no problems and everything should work correctly. But I'm not very happy with how we've had to write this out. I don't like the syntax of making meta tables. So I've made a shortcut of how we can make meta tables using the plugin. In order to make this exact same meta table, but using the shortcut, we do pretty much the same thing that we did over here. Now we need to use a different name because it's going to tell us there's a conflict. So I'm going to call this meta 1 and this one meta 2. And then all we need to do is pass in this part of the table, the part that matters. And here we can see this table has been inserted. Now to change this to a meta table, all we need to do is place another table directly after it. So now we can see it becomes a meta table, and we have this part of the table and this table, which is this over here. If we set this like this to have underscore underscore index, like so, now we can see that this and this are the same. But over here, we've defined it like this, where over here, we had to use this ugly syntax. And this shortcut also works with recursion. So if I add another table at the end over here, we can now see that this table that was placed into this meta table becomes a meta table itself. And if I add another table after that, that becomes another meta table within that meta table. So we can add as many meta tables deep as we want to go by just keep adding more tables. It's also not mandatory to use a table for a meta table. We can also use names. So for instance, I could use my global type B as the meta table. So if I replace all this with my global type B, now we can see meta 2 becomes a table with value number, and the meta table is my global type B. And the same is true. We can place this at the front over here. And now we can see that it becomes a meta table with my global type A at the front of the meta table and my global type B at the back of the meta table. Another feature the plugin provides is automatic generic type sorting. So what that means is, let's now delete these two meta tables. And if I change type B to be a generic, like so. So now we can see T equals any, and we can see we have a problem here. And the reason we have this problem is because it's a recursive type. Because we've defined global type A here, it's going to complain. Now, one way to solve this would be to change type A to also be a generic, like something like this. And now we can see the problem went away. But let's say we didn't want type A to be a generic, but we only wanted type B to be a generic, like so. So what we need to do is make sure it's not recursive by removing this. And now we can see we currently have no problems. But there are some edge cases where the order of these types are important. For instance, if I change type A to be a meta table, so we can just add a table to the end here. And now type A is a meta table. And now we can see it's complaining about type B. If we mouse over, it says recursive type being used with different parameters. Now, a way we can solve this problem is to simply place type A under type B. And now we can see the complaints go away. So how can we make the plugin automatically place this type under this type? Well, all we need to do is indicate to the plugin that this is a generic type and ask it to always place it above type A. And to do that, all we need to do is add the brackets. So now we can see type B goes above. If I remove the brackets, type A goes above. If I add the brackets again, type B goes above and type A goes below. So these brackets indicate to the plugin that this is a generic type and we want this type to always go above this type. And if we wanted to, we could also pass in a value for that type. So this is going to be a number generic. Or if we wanted it to use the default value of any, we could just leave it empty like so. Another feature the plugin provides is comments within comments. So the way that works is, let's make this no longer a meta table, and let's add a new value over here. So value, and let's just set this to a string, like so. Okay, so we have this value over here, which has a value which is a string, and we can see that over here. Now, if I place a comment inside of the comment, we can see that this value disappears. So here in type A, it no longer has the string value. If I remove the comment, it comes back. Another thing we can do is add block comments within block comments. But one thing we need to make sure we do is we need to make sure it's on a different level. To select the level, we can place equal signs inside of these brackets. And now this is a block comment with a level 1, and we can make it a level 2 by placing 2 equal signs, like so. If we just wanted it to be a level 1, we just need 1 equal sign in each side. And now we can see we have this block comment over here. Now at this current time, this block comment has no effect, but in the future, it may become handy, because let me show you a feature that Roblox has recently added that currently doesn't work for us. So if I make a function, and if I place a comment above this function, it could be a normal comment or a block comment. This is a function. And now if I type in ABC, we can see we get a description of that function based on this comment. But if I add a function over here, so let's say we add a function like so. And now if I try to use this function, so I'm going to say global my index A, and we can see we don't get a description for this function, even though if we add a comment, we can see we have no description. But there is a somewhat hacky way to make this work. Instead of defining our function like this, if we change this to type of and pass in a function into type of, like so, we can see we now have this type of over here, which is okay. And if we try to use the function, we can now see we get the description of this comment. So in this way it works, but the problem is I'm not a big fan of using type of when we don't have to. So I personally would be using this to define my functions. And then I would hope that in the future, Roblox would add support for comments above functions defined like this. At the time of making this video, this is all the features that this plugin provides. But in short, the job of the plugin, copy our types and copy our values over so that we get type checking. Now the framework will work without the plugin, but the downside is then you're going to either have to manually create these types, or you're just not going to have any type checking in your project. Let's now go over the functions that are provided inside of the module. So let's first simplify the 2 scripts we created and regenerate our module. So I'm going to delete local globals, so the plugin will regenerate the entire module. And I'm going to get rid of this, and I'm going to, I think I'm going to call this type A, or actually value A. Let's call this value A. Let's call this value B. And this is going to be a table. And I think I'm going to just have the values inside. So let's delete this and let's delete this. Let's also remove the generics. So let's remove this. So now we have our entire module back with all our functions, and we have 2 simple types with index A and index B. If we now add these values into these values. So I'm going to say value b dot value, which needs to be a number, equals 1, 2, 3, 4. And over here, I'm going to say value a dot value, which needs to be a string, equals a, b, c. And now what I'm going to do is say print global dot, and we should have my index AB. This is going to print my index A value, which should be a string, and this script is going to print my index B's value, which should be a number. Now, if we run the game, we should see that we get an error. What happened here was the order of script A and script B that they're running is random. So in this case, script A ran first, script B ran second. When script A ran first, it tried to use the myIndexB, but at this time, this function had not been called yet. So index B was not inserted into the global table. So here is saying we tried to index nil with value. So this myIndexB at this current time is equal to nil. But when script B ran and tried to index myIndexA, this was not nil because script A ran first. It had already ran by the time script B ran. So we can see that script B was able to print ABC correctly. This is where the initialize function comes into place. So what the initialize function will do is allow us to wait for the other scripts to have run before we continue. So there's two ways we can use this initialize function. One way is to say global dot initialize, and we can pass in a function into this function, and we can place this inside of this function. So this function is going to get called once all the other scripts have finished running. And we could do the same on the other side. So I can copy this over here and then replace this with this. So once all the scripts have initialized, it's going to call this function and print the value. So if we now play the game again, now we can see that we're able to print the values correctly with no errors. Another way we can use this initialize function is just to call it, but without passing in any function, like so. Now, the way this works is instead of calling the function once all the scripts have initialized, this initialize function is going to yield this script's thread. And once all the scripts have finished, it's going to resume the thread. So we have essentially the same result. So let's play the game again, and we can see it works correctly. One thing you need to be careful of is if one of your scripts never finishes, then you're going to have an infinite wait. So it's always important that your scripts finish. So for instance, if I add a while true do loop here with a task wait, now what's going to happen is this script is going to last forever, which is going to prevent the global module from ever starting the initialize stages for each script. So if we now play the game, we should see that the output never prints these values because we're stuck in this loop and the framework is constantly waiting for script A to finish. Let's just keep this infinite loop problem here for now, and let's move on to the start function. So the start function works just like the initialize function, but we can think of it as a three-stage system. So we first have the script stage, then we have the initialize stage, and then we have the start stage. So the initialize function will wait for the script stage to complete, and then once the initialize stage starts, the start function will wait for the initialize stage to complete. So currently this while true do loop is in the initialize stage. So let's place this loop inside of the start stage. So we can just call the function, the start function, just like we did for the initialize function. We can either pass in a function, or we could just call it with nothing and it will just yield this thread until the start stage. And over here, I'm going to say global start, and I'm going to pass in a function to call this function once we get into the start phase. And all I'm going to do is say print script script B start, and over here, before we start the infinite loop, I'm going to say start script A start. And if we now play the game, we can see that the initialize stages ran first. So we printed the value inside of the initialize stage and over here as well. And then once this initialize stage finished, the start stage started and we printed script A start and script B start. Just like placing a infinite loop inside of the script stage blocks the initialize stage, if we put a infinite loop inside of the initialize stage, then that's also going to block the start stage. So we can see if I place a infinite loop inside of initialize, it's going to cause the start stage to never start. So we should never have a infinite loop inside of the initialize stage. We can only have a infinite loop once we reach the start stage. Now let's move on to export and inherit. So the first thing I'm going to do is delete all this and all this. Now, let's say we wanted script B to inherit from script A. And let's say that script B also used a string value here. All we need to do is simply call the inherit function. So over here, I'm going to replace this and say global inherit. And then it's going to ask for which index we want to inherit from. We want to inherit from this index over here. So let's copy and paste this over. Then it's going to ask us the destination we want to inherit onto. We want to inherit onto value B. And then finally, it's going to ask us the mode that we want to use to inherit. For now, I'm just going to use clone. And then if we want to, we can pass in which things we want to inherit. We want to inherit value, but because it's the only thing we want to inherit from, we can leave it empty and then it will inherit everything. What I'm going to do now is say print value b.value, and then I'm going to wait for the initialization stage. So I'm going to say global.initialize, and then I'm going to print the value a second time. And now I'm going to run the game. So we can see that even though we inherited over here, the value was still equal to nil at this time. But once we reached the initialization stage, the inherit function took place. And now this value is equal to this value that we set over here. Even though it's possible to inherit once we reach the initialization stage, so if I move this down here and play the game again, we should see it still works. We should never really do this, because if we do it this way, then the framework cannot do dependency sorting, because when we call inherit like this, it's just going to instantly inherit. So if I add another print before the inherit, we can see it's 0, and then the inherit takes place instantly. But if we call inherit before we reach to the initialization stage, then the framework down here can apply the inheritance, but can also resolve dependencies. So it's always important that we inherit before we reach the initialization stage. Now, one thing you may have noticed is we never exported myIndex A to inherit it over in script B. And if we go up to the export function, we can see that the export function only adds the index and value that we pass in into this exports table. And then when we inherit, it will first try to get the value from exports, but if it cannot find it, it will fall back onto the globals table. And when we call this global function over here, we can see it adds it to the global table. So we don't always need to export. We only need to export a value if it's not inside of the globals table. Just for completeness, let me show you how the export function works. So I'm going to say global.export, and I'm going to just give this a ABC index, and then I'm going to pass in a table value equals, and I'm going to say zzz, and now instead of inheriting from myIndex A, we can inherit from ABC. And we should get this same value over here. So let's run the game and we see zzz. Let's now take a look at the inheritance modes. So we have the metatable mode and clone mode. And if we look over here, we can see that if we go into clone mode, what it will do, it will loop through the indices of the source. And if the destination index is equal to nil, so it won't overwrite any values that are already existing, it will just simply set that index to the value from the source value. And if we pass in some indices, it will only use them indices to clone the values in if they're equal to nil on the destination side. But if we use metatable mode, then all it does is sets the metatable for the destination to the source. But for the best performance, it's always highly recommended to always use the clone mode when possible. And the reason for this is if we check out Luau's website under the performance section, and if we go to fast method calls, we can see that over here it says, for performance reason, it's strongly recommended to avoid underscore index functions as well as deep underscore index chains. So that means that if you have a metatable that points to another metatable that points to another metatable, and you have a deep chain of metatables, it's not going to be great for performance when calling functions. So in order to not have that problem, it's recommended to use the clone mode and not the metatable mode. Let me now show you why you may want to use the metatable mode. So what I'm going to do is let's remove this over here and let's inherit from my index A again, like we did before. And what I'm going to do is first set this value to ABC, and then once we get to the initialization stage, I'm going to change this value to be CBA in lowercase. And then what I'm going to do is over here, I'm going to print the value, and then I'm going to say global start and print the value again. And if we now play the game, we should see that when we inherit from ABC, because we used clone mode, whatever the value was when we cloned the value, this value B will keep that value the same. It won't update with this value over here. So any changes we make after the clone will not be reflected onto value B. If we change the clone mode to metatable mode and play the game, now we should notice that it prints nil nil. And the reason for this is we haven't set underscore index. The framework doesn't do that for us. We could modify the framework to set it for us, but I like to set it manually. So over here, I'm going to say value A dot underscore index equals value A. Now this is going to complain because it doesn't know what this type is. We haven't set it up over here. So over here, I'm going to say underscore underscore index equals itself, like so. And now the warning will go away. And if we now play the game again, we should see it says CBA, CBA. So what that means is that this initialize ran first. So this got set first, and that's why it printed this twice. Now, if we did it the other way around, it would print ABC and then CBA, because we don't know the order that the initializers are going to run. But because this ran first, it printed CBA in both cases. So by using the metatable method, it will ensure that whatever updates take place in value A are also reflected in value B. What I could do is add a little task wait here. So that would ensure that this print runs first, and then we change the value, and then it's going to print it again. So let's press play, and now we can see it prints ABC and CBA once it's been updated. Another thing to take note is even if we're in clone mode, it doesn't do a deep clone. It only does a shallow clone. So if we clone any functions, it's not making a new function, it's just pointing to the function that this script points to. And if we clone any tables, it only points to the same table that this script is pointing to. So what that means is if I say remove this, and let's add a new value. So let's call it T and make it a table. And let's not forget the comma. And let me say value A dot T equals table, and let's set this to any, and let me say add in a value called ABC equals CDA, and change T, and let's add a new index into there. So let's say B equals hello, and then let's copy this type over, and then let's print T in both cases, and let's play the game. Okay, so we can see that even though we're using clone mode, because it's pointing to the same table that was created over here, when we update this table, the change does get reflected to value B. Let's now move on to this meta table function. First thing I'm going to do is let's delete all this, and I'm also going to comment out these 2 lines so they get removed completely from our global, and I'm going to close this script. Now in this script, let's create a basic class and object. So the first thing I'm going to do is let's delete this, and let's delete this, and let's delete this. I'm going to rename this to my class, and this is going to be called my class. And I'm also going to make another type, and this is going to be called my object. And we need to update this to say my class. And I'm going to add a new function inside of the class. So I'm going to say new. And this function is going to return a my object, like so. And let's now create this function. Let's rename this to class as well. Okay, so class, and we can see it has a new function, and we can say function class.new equals, not equals, and it needs to return a object. So if we return, now this object is going to be a meta table for class. So what I can do after the table, pass in my class, like so. And now we can see that my object has this and my class as the meta table. So over here, I'm going to say local object, or we could call it self equals, and we want it to be a meta table, and it's going to have a table, and it's going to have class as its meta table, and then we're going to return self. Now currently we can see it has a warning. Self could not be converted into my object caused by table type not compatible with this type. So it wants us to have this value in there. So let's say self.value equals ABC, and now we can see the warning went away. If we now try to add some more functions into our class, so let's add a print function. So print, and this function is going to take in self, which is going to be the object value, and it's not going to take in anything else, and it's not going to return anything back. So we're just going to define it like this. So let's now create this function. Function class. Now instead of a dot, we can use a colon here, because it's going to take in self. And now if we say self, we can see it knows it's my object. And if we press dot, we can see it knows that value is a string. So what I can do is just say print self.value. And now over here, when we create the object, if I try to call the print function, we can see it doesn't autocomplete because we didn't set this at underscore index to itself. So if over here I say underscore index is equal to my class, and over here let's set underscore index to itself. Now we should get autocomplete with print and we can see underscore index, the value, we see the new function, and I could print. And if we did run the game, but over here, let's run the new function just to create an object. Press play. We get a problem, which is over here. And the reason for that is, oh, I used a equal sign here. That was a mistake. I was meant to use a dash. So let's play the game again, and now it works. You can see it prints ABC. Let's add another function. So let's call this one set, and it's going to take in self, just like before, which is going to be my object. And it's also going to take in a value, which is going to be a string, because this is a string as well. And it's just going to return nothing, like so. And then let's create the set function. So I'm just going to copy and paste this, change this to set. Now we need to take in this value, and it's automatically going to know that this is a string type because we defined it over here. And then I can say self.value equals value. Now, if we had made a mistake and set this to a number, then we would have got an error over here. You can see it says that type number could not be converted into string. So by changing this to a string, it makes the problem go away. What I can do now is we can remove this print from over here. Over here, when we call new, I can save the object. And then I could say object. I can call the set function, and it's going to say we want a string value. So I'm going to pass in a string. Let's say AAA, and then let's say object print, and let's run the game. And we can see this time, instead of printing ABC, it prints AAA. So most of you who are familiar with making classes should be very familiar with this code already. But I personally have some small things I like to change due to personal preference that are not mandatory for you to change. So if you are happy with how this works, you can keep everything like this. But if you want to see how I do it, I'm going to show you what things I change to this structure. The first thing I don't like is seeing underscore index inside of my autocomplete. So when I say object dot, we can see this value here, and I don't like seeing this here. So what I want to do is make this go away. So there's a few ways we can go about doing this, but the main thing we need to do is remove it from our class. So once we remove this, we're going to get some warnings. So what we need to do is tell the type checking engine to still use this as underscore index. So what I'm going to do is wrap this in a table like so, and I'm going to say underscore index is equal to my class. And now we can see that this problem goes away. We still have some errors, but now at least the set and print functions work. For now, let's comment out this error we have here, and let's just move on to this. So what it wants us to do is not pass in the class directly, it wants us to wrap it in a table. Now we could wrap it in a table like this, and that should solve the error, and now we have no errors. But the problem with this is now every time we create a new object, instead of just creating one table, we create two tables, a meta table and a table, and it's always better to just have the class point to itself as an index. So doing this is not really that great, but this is one option we have. What we could do is reuse this same table over and over again. So over here, I could say local meta equals and create the table over here instead. And then every time we create a object, reuse the same meta table over and over. Another option we have is we could just brute force the type checking engine to accept class as the meta table. So let me show you how we can do that. We don't need this meta table anymore. And we could add underscore index again. And what we want to do is we want to first cast this into a any type. So I'm going to say any. and that should make the problem go away. But we might also want to cast it back into the object type. To do that, we're going to wrap it around with brackets and cast it a second time into global my object. So now self is equal to my object, and Roblox is not complaining. We still have a complaint about this. We can solve this by saying class. Now instead of using dot, we could use brackets here and use underscore underscore index equals class. And now we can get rid of this, and this does the same thing. So now we've brute forced Roblox into supporting this way of setting the meta table. If we now go back down to here and type in object dot, we should see that we no longer see underscore underscore index. This is where the meta table function comes in. So here we can see I've created a meta table function, and the main purpose of this function is just to improve this syntax, because this is kind of ugly having to do this every time we want to make a new object, and also so we don't have to keep defining underscore underscore index as itself. So the meta table function works in three ways. We can pass in no tables. If we pass in no tables, it's going to create a table for us. It's going to set underscore underscore index for us and return the table, but as a any type. And then we can either pass in one table. If we only pass in one table, it's going to create a meta table, and that one table we pass in is going to be set as the meta table, and it's going to create a table at the front for us. Or if we pass in two tables, then it's going to use the first table at the front of the meta table and the second table at the back. So let's now use this meta table instead of using this and having to set this. So what I'm going to do is, so we don't have to set underscore underscore index, over here I'm going to pass in a value. So I'm going to say global dot meta table, and that's going to create the table for us and set underscore underscore index for us. So now I can remove this, and this does the same thing. The next thing is I want to change this. So I'm going to say local self equals, and I'm going to use the meta table, but I'm not going to pass in the first table. I'm only going to pass in the meta table section. So I'm going to say global meta table. I'm going to pass in class, and we can see that self should be equal to any. Let's comment this out. So we can see it's equal to any. So now I can just cast it to the object like so. So now this and this both do the same thing. Just this one looks a little bit nicer. So we can now remove this, and that is the purpose of this meta table function. Another benefit of brute forcing the object type onto self here is we can now merge these two types into a single type. And another thing is we can get rid of the meta table completely, which will in turn get rid of type of. And this is going to improve when we start creating generics, because having two separate types like this can make it a little bit complicated when working with generics. But if we can merge them into a single type and no longer use type of, it will greatly improve our experience when working with generics. So what I'm going to do is I'm going to copy all these functions down to the object, and I'm going to remove the class as the meta table, and I'm going to remove the class type altogether. So now we just have a single type, which is a normal type. We don't use type of anymore. Then what I'm going to do is I'm just going to cast the class as the object. So over here, it's going to be called my object, and we should see we get no problems. Everything seems to be working fine. We don't have no problems over here, and all our functions should work correctly. We can see we get new, set, print, and if we use a colon, we get these correctly. So everything still works correctly. And if I check over here, say self, we can see the functions work and everything works. There we have it. We've covered every function inside of the global module. Now, one more thing I can show you is that if you like, you can change these functions or you can add your own functions. So down here, I could say hello equals function. And then now if we go over here, I can type global, and we should see that it has hello as the function. So if you want to add your own custom functions, you can add them over here, and then everyone should have access to them through the global variable. But it's not recommended to always add functions here. You should only add functions here that are correlating to the framework. If you just want to add a random function into global, then it's better to do it through the method I showed before. You want to call global, you want to pass in the index. So this is going to be called hello, and it's going to be a function. And then we want to cast this so the plugin knows that it's a function, like so. And now we should see that over here the hello was added, and now even though we never added hello over here, we should see hello inside of global, and here we can see hello. So this is the correct way to add values to the global variable, but if there's something that's core to the framework that you want to add, then you can add it over here. Now that we have a good understanding of how everything works, let's now make a small game using the framework. So the first thing I'm going to do is I'm going to delete script B, and I'm going to reset this script just in case there's any changes I made by mistake. And then I'm also going to delete most of this. Let's delete all this over here. And let's see, make sure that our script module reloaded, and it did. Okay, what I want to do now is let's just close this global module because we don't really need to see it while we're working on our scripts. And I'm going to rename script A to be called player object. And this is going to be an object for every player that's online. So I'm also going to rename the type to be called player object. Now, instead of these values here, let's change these to store different values. So the first value I want a player object to have is the instance value. And this is just going to point to the player's instance object. The next value I want is to know if the player is still online or not. So I'm going to say online, and it's going to be a Boolean value. Instead of having a new function to create a player object, I'm going to use the player added to create a new player object. And then we're going to create a collection. Now inside of our library, we have a collection script. We're going to use this script to store a collection of players when they are entered into the game, and when they leave the game, we're going to remove them from the collection. So instead of having this class being a global value, I'm just going to have it as a local value. So we can just remove this global call, like so, and I can cast this as the player object. And if we now look inside of global, we should see we no longer have the player object inside of here, but we still have access to the player object type up here. Now I'm going to delete these functions, but I'm just going to comment this function out so we can use it as a reference later on. And what I want to do now is create two functions for when a player is added and when a player is removing. So first thing I'm going to say is local function player added. We're going to receive the player instance, and this is going to be our function for now. Let's also create the player removing function. And once a player is removed, this function is going to get called. And let's now connect these two functions. So at the bottom over here, I'm going to say game players player added connect. I'm going to connect the player added function. And now I'm going to connect the player removing function. Now our player added function is going to work just like the new function that we use over here. So I'm going to copy and paste this over here to the player added, and we can now delete this. And what I want to do is make sure this points to the correct type, which is the player object. And now we have our object over here. So let's set up these values that we set over here. So self.instance equals, we need to pass in a player instance, which is this value over here. Now currently it's set to A, but Roblox is going to infer that it's a player once we set it. So if we mouse over now, we can see now it thinks it's a player. Where before we set this value, it said it was a value, which means it still wants to infer what it is. And once we set it to this, because it knows that this needs to be a player, it's going to assume that this is also a player. Okay, the next thing we're going to do is set the online value. So I'm going to say self.online equals true. Let's now bring in the collection script into our project. So the first thing I'm going to do is inside of global, I'm going to create a new folder, and I'm going to name this library. Now you don't have to do it this way, but I'm just going to do it like this so that we can see the difference between our custom scripts that we've made during this video and scripts that were pre-made in the library. And what I'm going to do is just move these scripts over as we need them. So we want the collection script. So let's move this collection script over to library, and I'm also going to enable it. Now, if we look at this collection script, we can see that it uses global event. So it wants to use events to create the inserted and removed events. So we're also going to need to bring in this event script. So let's enable this as well. And if we now update, we can see that the error went away. If we move this back and update the script, we can see the error comes back. So we need to make sure we have this event so that these errors go away and it has the ability to use events. Now, another problem we have, if we look at event, we can see that we use global defer, not task defer. Now we can replace these to say task defer, just like we did over here. But the problem is, well, it's not really a problem. If we use global defer, which is from this thread script, here we can see we create 3 functions. This script does thread recycling. And if we recycle our threads, we get about 2x the performance compared to creating new threads every time we defer. So I personally like to use this thread script. Now, if you don't want to, you could just replace these to task defer, but I'm going to use these threads over here, recycling threads. So I'm also going to bring in threads into the library and enable this. And now we should see if we make a change here, we can see that the errors go away. Okay, so we now have collection. Collection relies on event, and event relies on thread. Let's now create a collection from this collection script. So over here, I'm going to create a new local variable called player collection, and it's going to be equal to, and I want this to be a global value so that everyone can access this collection. So I'm going to call the global function. And for the index, we can call it anything we want. I'm just going to call it players. And then we're going to pass in a custom value, and we're going to pass in the value by calling this collection function over here. So over here, I'm going to say global dot, and we should get the collection function over here. And then we need to cast the type, because if we look inside of global, we still don't have players over here. Once we cast the type, so I'm going to say for the type, I'm going to say global dot collection. And now we should see players gets added over here. Now, one thing we can do, if we look at the collection script, we can see that this collection script supports generics. Now, by default, the index, which is A, and the value, which is B, is equal to any. But that's not what I want to happen. So if we go back to the player object, I want the index of the collection to be the player instance and the value to be the player object. So over here, I'm going to go open, close brackets, and for the first index, it's going to be player, and for the value, it's going to be the player object. Now to pass that in, we have to say global dot player object. So now it's going to know that the player object, the value for this collection is a player object. So one way we can test that, if I say player collection dot, if we pass in just a random value, it might complain because it wants a player object here. But if we just ignore that, we can see it has the correct type check-in over here. Okay, so now we have our collection set up with the correct types. Let's now insert the player object into the collection. So over here, I'm going to say player collection. I'm going to use the insert function. And because we defined the types in the generic, we can see it wants a player and a player object. So let's say insert, and for the player, we're going to pass in the instance. And for the player object, we're going to pass in self. When a player is removed, if we look at the collection script, we can see we can remove the function like this. We pass in the index and it's going to return the value back to us. So let's go over here and say player collection, remove, and we want to pass in the index, which is a player. And this is going to return the player object. So over here, I can say local self is equal to this. And if we check self, we should see that it has autocomplete because it knows it's a player object. Okay, so now we want to set online to false once they remove from the game. So self.online equals false. Okay, so another small thing I want to change. This is just personal preference. You can keep it as class if you want, but I'm going to name this player instead of class. But it's not important that we do this. It's just personal preference. And another thing we need to be careful of is here you can see that we're using global collection, which is from the collection script. But we don't know at this time, has this collection script run yet? This collection function may not have been set at this time. So if we play the game, this could cause an error. So what we need to do is we need to go into the initialization stage. So to go into initialization stage, just call global initialize. So now we can ensure that once this thread resumes from this function, that this collection is going to exist at this time. So now we've solved that problem. Now we've kind of introduced a different problem because of this initialization function, because this is going to yield the thread until all the scripts have run. Now currently all these scripts run very quickly and will return instantly. None of them have a task wait inside of them. So this initialization will be almost instant. So we don't technically have this problem now, but we could have this problem in the future if one of the scripts that we add in the future take longer to get to the initialization stage. And the problem is over here, when we add the connection for player added, a player may have already been inserted into the game by the time we enter the initialization stage. So because we've added this, we also now need to loop through the players and just double check to make sure no players have already been inserted into the game. So over here, all I'm going to do is say for index instance in game players get players, and then I'm going to use global spawn. The reason I'm using global spawn because inside of this function we're going to load the data store, and when we load the data store it's going to block the loop, and we don't want this function to block this connection from being added. So by spawning the thread, it's not going to prevent these two events being connected straight after the loop. You'll also notice that I'm using global spawn, not task spawn. If you want to, you can use task spawn here. It will have no effect, but by using global spawn, we're recycling threads. Another thing is, it's always best to connect to events once we've entered the start stage. The reason for this is, let's assume that the player object relied on another script that needs to initialize first. Well, if we connect it now while we're in the initialization stage, another script may not have been initialized by the time this object has been created. So it's kind of important that our events always get connected in the start stage. So over here, I'm going to say global start, and that's going to ensure that all scripts have finished initializing by the time we start adding player objects. Let's now start working on the player's data store. So what I want to happen is I want the data store to save every 30 seconds. So in order to have a clock that keeps updating every 30 seconds, I'm going to use a timer. But here we can see we have two types of timers. One is a perimeter timer and one is a normal timer. The perimeter timer relies on the perimeter event, where the normal timer just relies on the normal event. But I want to use the perimeter timer. Now, because that's going to rely on the perimeter event, let me try to show you the difference between the two. They're almost the same. So let's open event and perimeter event and place them side by side. Now, the main difference is when we connect a function to a normal event, it only takes in a function. But when we connect to a perimeter event, it takes in a perimeter and a function. And then when we fire the event, the perimeter event will pass that perimeter back as the first perimeter for that function, where the normal event does not. Now, the perimeter event works really well with object-oriented programming, but if you don't need perimeters like this, then you can use the normal. But in this case, we're going to need the perimeter event. So let's bring in the perimeter timer as well and enable this. And if we look in here, we can see it inherits from the perimeter event. If we look at perimeter event, we can also see that this inherits from the normal event. So this relies on this, and this relies on this. Another thing we'll notice is that perimeter events also use generics, and we can set a value for A. Currently it defaults to nil, but we can set any value we want. And if we look, the perimeter is equal to A. So what I'm going to do is come back to player object, and I'm going to make a new type property, and this is going to be called timer, and it's going to be equal to a perimeter timer, and I'm going to pass in the player object. So if we look over here, this A over here is going to be equal to player object, not nil. So before we set up our timer, I also want to make a save function. We have two options. We can make a local save function that no one else could call, or we can make a global function that goes inside of the player object. Now, the local function would be simpler to make, but I'm going to make it the complicated way. That way we can call the save function whenever we want, and that's going to allow us to force the save to happen earlier than the 30-second timer. So what I'm going to do is add a new function called save, and it's going to receive self, which is the player object. Then over here, I'm going to say function player, which is this value over here. Yours may be called class, and I'm going to use a colon, save. Inside of this save function, all I'm going to do for now is print, and I'm going to pass in self.instance.name. Now that we have our save function, let's set up the timer to call the save function every 30 seconds. So over here, I'm going to say self.timer. Now this needs to be a perimeter timer. So I'm going to say global perimeter timer. And then I'm going to connect this timer to this save function. So I'm going to say self.timer. And here we can see we have a connect function. So let's call connect, and it wants a perimeter and a function. The perimeter needs to be a player object because that's what we set it to be up here. So we want to pass in self, and then it wants our function, and this function has to have the player object as its first perimeter, which is self. So over here, I'm going to pass in self.save. And this should work correctly. So hopefully we can now see why we wanted to use a perimeter timer over a normal timer, because a perimeter timer will allow us to pass in self as the perimeter, so we can get self from over here. Finally, let's now start the timer once we've connected it. So self.timer, call the start function, and he wants a duration. Now, normally I would save the data store every 30 seconds, but just for testing, I'm going to set it to 5 seconds. Now, another thing I want to do is once we printed save, I want to start the timer again. So it saves again after another 5 seconds. So I'm going to say self.timer, and I'm going to start the timer again for 5 seconds. Now, one thing I need to make sure to do is when the player leaves, we want to stop this timer, preventing it from calling the save function again and continuing the loop over and over again. So after we set online to false, over here, I'm going to say self.timer, and I'm going to call the stop function. If we now play the game, we should see that every 5 seconds, it should print save with my player's name. If we wait another 5 seconds, it should print again, and if we wait another 5 seconds, it will print again, over and over. So let's now create the player's data property, which is going to store the data stores table. So over here, I'm going to create a new property called data, and we could just set this to any, like so. And that's going to allow us to add any values into the data store. But if we want to, we can hand write the properties of the data store so that we get autocomplete for the data store as well. We could write it directly in here over here, or we could create a completely separate type for the data store. So let's just create a separate type. So over here, I'm going to make a new block comment, and I'm going to type player data equals table, and I'm going to have two values, one called level, which is going to be a number type, and I'm also going to have one called coins, which is also going to be a number type. And now, instead of pointing to any, I'm going to place this player data into here like so. And now if I go over here and say self.data, we can see it says player data. If I press dot, we can see we get coins and level autocomplete inside of our data store. Let's make a data store loader. So I'm going to remove this. Now I want the data store to load before we start the timer. So over here, after we've created a timer but not started it and haven't connected to it yet, what I'm going to do, the first thing I'm going to say is local success data, and they're both going to be equal to nil. Then I'm going to start a loop, and we're going to keep trying to open the data store. So over here, I'm going to say while true do. Now, the first thing we're going to do is use get async with the data store, but I'm not going to do that for this video. I'm just going to make a little fake get async function, which kind of works just the same as get async, but I'm going to make it slightly different. What I'm going to do is I'm going to say success is equal to math random below 0.5. So there's a 50% chance that success is either true or false. And then data is just going to be equal to the table with level equals 0, coins equals 0. And then I'm going to add a small task wait, because get async is a asynchronous function, which this is going to emulate the asynchronousness of this function. And I added a little comment here so that you know that you need to replace this with get async. Okay, so once we've loaded the data store and got our value and determined if it's successful or not, what I want to do is I want to check to make sure if the player is still online, because during this time, if a player left the game, we don't want to continue. We want to return and do nothing. So over here, what I'm going to do is say if self online equals false, then return and don't continue the function. But if they are still online, then I want to check to see if it's successful. So I'm going to say if success, then break out of this loop, else we're going to give a warning, failed to load, and we're going to pass the name of the player, data store, and then we're going to wait 5 seconds and try again. Now we can keep trying over and over again, either until the player goes offline and then we're going to return, or if it's successful, we're going to come down and continue the rest of this part of the code. Now, if it is successful and we get down to here, we want to set this data value into the player's data. So over here, I'm going to say self.data equals data. And just so that we know that it loaded correctly, I'm going to add a print. I'm going to say print loaded, and I'm going to pass in the name of the player, data store, and I'm also going to pass in the data value, which should be always this for now. But if you was using a real get async function, then this value will change as the data store changes. So we've run into a slight dilemma. So here we can see that once the data store has finished loading, we start the timer and then we finally add it into the collection. Now, one thing we could do is add the player object into the collection before the data store has loaded, or we could add it after the data store has loaded. Now, if we add it before the data store has loaded, this means that this data value may be nil when a other script accesses a player from this collection. So what we would need to do is place a little question mark over here to indicate that data may be a nil value and force other scripts to always check to see if data is not equal to nil. But I don't like to have to keep checking to make sure that data is not equal to nil. I want to make it so that a player is only within the collection after their data store has loaded. So I'm going to remove this question mark so that we can say that the data will always be loaded when you access a player from the collection. But the problem we have is, see how we try to get the player when a player is removed from the collection? Well, if a player leaves while we're still loading the data store, the player is not been inserted into this collection, so self here is going to return nil. We don't have access to this player object until we get to this stage. And we don't know if this player removing is going to fire once we get to here, or it may even fire before the data store has finished loading. What I'm going to do is, instead of relying on the collection to get the player object when a player is removed, I'm going to make a separate local table to store player objects that we can rely on to get the object even if the data store has not loaded yet. So over here above the collection, I'm going to say local players equals table. And then over here, as soon as we make the player object, I'm going to insert the player into the players table. So I'm going to say players instance equals self. That way, even if the data store hasn't loaded, we still can use this table to get the player. So what I'm going to do now is I'm going to remove this over here. And over here, we're going to get self, not using the collection, but using this local table instead. And then once we get the player object, we can remove the player from this table. So I'm going to say players instance equals nil. So let's now work on our save function to work more like a set async. So the first thing I want to do is, instead of just printing, I want to add a little task wait to emulate a set async. So over here, I'm going to say task wait 0.2, and I'm going to add a little to do saying to use set async instead of this task wait. But for now, we're just going to emulate the set async with a task wait. And I'm also going to improve this print just to make it match this print over here. So what I'm going to do is say print saved. I'm going to pass in the instance data store, and I'm going to pass in the data that we saved. Okay, let's now remove this print. Now we have a new problem. Because we added a task wait here, what could happen is, as we're saving, the player could leave, which would stop the timer, but would allow the timer to start again once the save finishes. So we could stop the timer here, the save wait could finish, which would start the time again, which would cause the save to continue while the player is offline, and we don't want that to happen. So what we need to do is check after this wait to make sure the player is still online to start the timer again. So over here, I'm going to say if self online equals true, then start the timer end. So now if the player exits the game while we're in the middle of saving, it won't start the timer again after the save. Because this save function is a public function, meaning that other scripts can call this function, we also have another small problem, and that is if someone calls this save function and in that very same moment the timer finishes, then the save function is going to be called twice in a row. So we don't want that to happen. So what I'm going to do is at the top, when we have the save function first starts, we're going to stop the timer. Now, if the timer is already stopped, this stop function doesn't do nothing. But if the timer is running and someone manually called the save function, it's going to stop the timer, preventing it from being called, the save function from being called again. And then after the wait, we're going to check if they're still online and start the timer again. So this should prevent the save function from being called multiple times if the timer and it's being called manually at the exact same moment. Another thing I want to do is when a player leaves the game, I want to save their data store one last time. So over here, I'm going to call the save function. So I'm going to say self save. Now, one thing we need to be careful of is remember that we get in the player object from players, which gets added before the data store has been loaded. So there's a possibility that over here, the data store has not been loaded yet, and we're going to save a value that hasn't been loaded. So it's very important that we first check to see if the data store has been loaded. Now, normally when we access player objects through the collection, we won't need to check, but if we access the player through this players table, the local table, then we do need to make sure that the data store has been loaded. So I'm going to say if self.data, then we're going to save like so. Now, another thing we could do is see how we only insert the player into the collection after the data store has been loaded. So in this case, we remove from the collection over here. Now, this doesn't actually have a problem because if we look at collection, we can see that when we remove, it does a check for us over here. Only if it's not equal to nil will it be removed. So having it over here, it has no problems, but we could just optimize slightly by moving it into here. And that way we will only call this function if the player's data store has been loaded. Now, another thing that we can do, see over here how we're stopping the timer, but when we call the save function, we're also stopping the timer. So we could remove this stop and just rely on this save function to stop the timer for us. Now, if data hasn't been loaded, the timer hasn't been started, so we don't even need to stop the timer if data is equal to nil. So we don't technically need to stop the timer over here. We can just rely on the save function to stop it for us. Okay, so we still have one slight problem, and that is when a player is removing, if the server is shutting down at that very moment, it's not going to wait for this save to complete. We're going to need to use bind to close to prevent the server from shutting down until this final save has completed. So what I'm going to do is I'm going to rely on this players table, and as long as there's still a player within this table, I'm going to keep the server awake. So I'm going to check this players table. If there's still a value inside of this table, I'm going to prevent the server from shutting down. So down the bottom over here, once we start going to the start stage, I'm going to say gain bind to close. I'm going to create a function, and inside of this function, I'm just going to keep looping, and I'm going to say while there's a next value inside of players, do a task wait. As soon as this next returns nil, it's going to break out this loop and allow the server to shut down. But there's one thing we need to change over here. See how we're setting this players to nil at the top before we've called the save function? Now this is going to still allow the server to shut down before this save has completed. So it's very important that we set this value to nil only after the save has completed. So I need to move this down to take place after the save. And that's going to ensure that this bind to close is going to keep the server awake until this save finishes, and then we remove the last player from the players table, which is going to allow the server to shut down. Okay, so there we have it. We've essentially finished our player object with data store, but there's one small improvement we can make. Now, most of you guys have heard of session lock-in for data store to prevent the data store from opening the data store before it's been saved on the previous server. Now, while session lock-in is a pretty cool feature, it does have some downsides. Now, there is a other option we have other than session lock-in, and it's actually a very simple solution, and it has almost no downsides to it. And let me show you how we can add that solution. So all we need to do is add a task wait, and I'm just going to add a little comment saying give time for the previous server to save. And after this wait, if the player has left, I need to make sure that they're still online. So I'm going to say if self online equals false, I'm going to exit and not continue. But if they're still online after 5 seconds, I'm going to start loading their data store. So this is going to give enough time for the previous server to save. Now, if you wanted to be even safer, you could increase this duration to 10 seconds or even higher. But I feel 5 seconds is pretty good for this demo. And this is going to allow us to not need session lock-in. Let's now play test the game to see if everything works. So after 5 seconds, it should attempt to load the data store. We can see there was a 50% chance of failure, and it failed on the first attempt. And we can see on the second attempt, it never failed and it loaded the data store. Now we can see every 5 seconds, it will continue to save the data store over and over again. And once I stop the game, we can see it saved one last time before the server shut down. One last thing we should change is saving every 5 seconds is probably overkill. So I'm going to change the timer to run for 30 seconds instead. So when we start the timer, it starts with a 30-second delay, and after a save, it also has another 30-second delay before the next save. Let's now create leader stats for our player object. So over here, under data, I'm going to store 2 int values inside of the player object. Now, if you wanted to, you could place it in a table instead, or you could just access it directly through the folder. But I feel I want to store the int values directly in the player object. This is just personal preference. You can do it any way you like. So what I'm going to do is say level value is equal to int value, and coin value is also equal to an int value. Then down here, when we load the data store, after it's been loaded, I'm going to create a leader stats folder, name it leader stats, place it inside of the player instance. I'm going to create a int value. I'm going to store it using this same key over here that we used, level value, set the name, set the value to match the value that we loaded from the data store, place it inside of the leader stats folder, and do the same for coins. So now if we play the game again, we should see that we now have leader stats. But remember, this takes place after the data store has loaded. So now once the data store loaded, we can see 0, 0. Let's now create a item object. So normally I create 2 different types of item objects. One that's for placing into the world, into workspace, and another item object for placing inside of the player's inventory. Now in this video, I'm not going to show you how to create a player inventory, but I am going to show you how to make the world item. So inside of global, I'm going to create a new script, and I'm going to name the script world item. Now this script, let's move it to the front like so, and I'm going to make this a strict script, and I'm going to make a new type for this item, so like so, and I'm going to name it world item like so. I also want to require the global module, and I also want to add 2 values for this type. So the first value is going to be instance, just like we have for player. So over here, I'm going to say instance is, and items are going to be mesh parts. If you're going to use models, you could set this to models, but I'm going to use mesh parts for my items. And I also want a destroy function in order to destroy a item. The next thing we want to do is make the class object. So let's copy and paste this, but I'm going to name it world item, and it's going to use the world item type like so. And then I also want a folder to be placed into workspace, and all items are going to be placed into this single folder. So over here, I'm going to say local folder equals instance new folder. I'm going to set the folder's name, and then I'm going to set the folder's parent. And then I want to create a collection, just like we did over here for players. So I'm going to copy and paste this. And another thing I want to do is I want to make sure to initialize to get into the initialization stage. So we're using the same index. What I'm going to call it is not players, it's going to be called world items, like so. And this is going to be called world items, world item collection. And this is not going to be a player, this is going to be a mesh part, and it's going to store a world item. So what I'm going to do now is create a global function that we can use to create items. So over here, I'm going to say global, and I'm going to call this, and I'm going to set the index to item. So if we call this item function inside of global, we can create a item. So it's going to be a function type, and this function is going to receive a name for the name of the item and a position for where we want to position the item. Then I'm going to cast the type so it gets added into the globals module correctly. So it's going to be a function, and it's going to receive a name, which is a string, and a position, which is a vector free. We could use a C-frame, but I'm going to use a vector free for this demo. And it's going to return a world item. So over here, we're going to say global.world item. And now if we look inside of here, scroll to the top, we should see that we have an item index, which returns a world item. Before continuing this script, let's create an item to test. So inside of workspace, I'm going to create an item. I've already created one, so it's just a mesh part. And inside I've placed a particle emitter just to make it look a bit nicer. And all I'm going to do inside of server storage, I'm going to create a folder. And I'm going to name this folder items, and I'm going to place this coin into the items folder. Okay, so now if we go back to the world item script, now let's create our object inside of this function. So the first thing we're going to want to do is create the object using meta table. So just like we did inside of player added, we can just copy and paste this over here. So it's going to work almost the same, but instead of using the player as the class, we're going to use world item as the class. Instead of casting it to player object, we're going to cast it as world item. And then we're going to clone this coin inside of the items folder and store it as the instance. So over here, I'm going to say self.instance equals game server storage items, and we're going to use the name that we passed into the function as the name to find the name of the item, and we're going to clone it. And then we're going to set the position using the position that we passed in. So self-instance.position equals position. And finally, we're going to parent this instance into the folder. So I'm going to say self-instance.parent equals folder. And we also want to add this object into the collection. So we're going to use the insert the same way we did over here for player. So I'm going to say world item collection, insert the instance as the index and the object. And finally, we want to return self back to whoever called this function. So I'm going to say return self. Okay, let's now create the destroy function. It's going to be very simple. All we can do is create the function inside of the class object, and then we're going to remove it from the collection. So we're going to say world item collection removed, and we're going to use self.instance to remove it. And finally, we're going to destroy this instance. So we're going to say self.instance destroy. Let's now create some item spawners that's going to spawn these items for us. So what I'm going to do is I'm going to place this back over here and go back into workspace. I'm going to create a new folder, and I'm going to name this folder spawns. And inside this folder, I'm going to create a part. And for this part, what I'm going to do is I'm going to set cast shadows to false. I'm going to set a yellow color, and I'm also going to make it neon so it's easy to see. And I'm going to say size equals 1. I'm going to set the position to 0, 3, 0. And I'm going to turn off fluid false. I'm going to turn off can collide, can query, can touch. I'm going to turn anchored to false to true. And I think that's all I'm going to set. Okay, so now what I'm going to do is give this part the same name as the item I want it to spawn. So currently we only have one item, so we have no choice but to call it coin. And I'm not going to just have one spawner, I'm going to have a few spawners. So let's move these spawners around. So I'm going to have one spawner over here. I'm going to have one spawner over here and another spawner over here. Let's now create our item spawner script. So inside of global, I'm going to create a brand new script. I'm going to name the script item spawner, and I'm going to move this to the front like so. And it's also most of the stuff is going to be the same. I want it to be strict. I want to have a type, and I'm going to name it item spawner, and I'm going to get global, and I'm also going to make a class, but I'm going to name it, give it the item spawner type, and name it item spawner. Item spawners are going to have a name value, which is going to be the same name that we pass in over here. So we know which item to spawn. So over here, I'm going to say name equals a string. And we're also going to store a position, so we know where to spawn the item. So position is a vector3. And we also need a timer, so the spawner can keep spawning new items after a delay. So I'm going to say timer equals perimeter timer, and we're going to set the perimeter as the item spawner. Now what I want to do now is I want to loop this spawns folder, and for every part inside of this spawns folder I'm going to create a item spawner. So the first thing I'm going to do is say for index child in workspace dot spawns get children to get all the children, and we're going to loop through these children, and just like we did over here we're going to create the self object. So I'm going to say local self equals global meta table item spawner, and I'm going to cast the item spawner type onto this object. Then I'm going to set the name based on the child's name. So these children have their name set to the same name as the item. So I'm going to say self.name equals child name. And we're also going to use the position of these parts to set the position of the item spawner. So I'm going to say self.position equals child.position. Let's now create the timer object. So over here, I'm going to say self.timer equals global perimeter timer. And then we need to make a function to be called when this timer completes. So over here, I'm going to make a local function. It doesn't need to be inside of the timer spawner because no one else needs access to this function. Now, because this is a local function, sometimes local functions are not able to infer the types that we pass into them. So I'm going to cast self to be a item spawner. So we get autocomplete for this self object over here. And inside of here, I'm going to call this function to create a new item. So I'm going to say global item. I'm going to pass in the name of the spawner and the position of this spawner to create a new item. And now I'm going to connect the timer to this function. So I'm going to say self.timer connect self. So I'm going to pass in the perimeter of self. So we get that same perimeter over here. And I'm going to pass in this function. So it calls this function once the timer ends. Another thing I want to do is once we've saved all this position and names of these parts, there's no need for these parts to stay in workspace. It's just going to replicate to the client for no reason and waste network data. So we can just destroy this folder so that it doesn't get replicated to the clients. So once we've finished looping through the items, we can just simply say workspace spawns destroy. Now that everything's set up correctly, all we have to do now is start the timer. So we could go self.timer and call the start function, but we can also start the timer directly if we pass a duration directly into the constructor. So you can see that we can also insert a number here. So what I'm going to do is say math.random, and I'm going to spawn the item between 5 or 10 seconds. Now, one thing we need to be kind of careful of is, so we can see that after 5 to 10 seconds, this timer will finish and it will call this function, which will try to create an item. Now this item is this function, the item function is inserted into global after initialize. Now, even though we have this really long wait here and the chances of this function not being created after 5 to 10 seconds is almost 0, I always like to be 100% safe with my code and make sure that it will always work 100% of the time. So what we need to make sure is that this timer only starts once we go into the start stage, because if we try to do it inside of the initialization stage, we don't know if this function has been added yet. So what I'm going to do is over here, I'm going to say global start, and that's just going to ensure that if this timer ends very quickly that this global item function has already been inserted. Let's now move this script back over here and let's play the game, and we should see after 5 to 10 seconds the items spawn around us. What I want to do now is I'm going to create this world item object, but one for the client side, so that the client can detect when it touches the item and send a remote event to the server, asking the server to pick up the item. So inside of replicated storage, I'm going to create a module script, and I'm going to name it global, just like I did for the server. And I'm also going to give it the global types attribute. So over here, I'm going to give it a Boolean, call it global types, press save and set it to true. Now inside of this module, I'm going to create a script. Now for scripts to run inside of replicated storage, the script has to have a run context of client, and now this script will work inside of replicated storage. Now I'm going to name this script world item, just like we did for the server. And what I'm going to do is I'm going to copy this to make it strict. I'm also going to give it the world item type, like so. And I'm also going to have instance set to mesh part. We're not going to use a destroy function like server, because the client is going to use child removed to detect when it's added or removed from this folder. Unlike the server, we're not going to create a folder. We're just going to wait for this folder to replicate to the client. So over here, I'm going to first get the global module, and I'm also going to create the world item class. And then instead of creating the folder, we're going to wait for the folder. So I'm going to say local folder equals workspace, wait for child items, which is the same name that we set over here. And then I want to wait for initialize. And I'm also going to make a collection on the client side as well. So both the server and client have a collection of items. Now we would notice that we don't have collections on the client side, because remember the server uses a different global and the client uses a different one. So over here, it doesn't have collections. So what we need to do is, just like we did on the server, I'm going to create a folder called library, and we need collections. So I'm going to copy collections over to the client side. And remember, collections relies on events. So I'm going to copy events, and events relies on threads. So we're going to copy threads over. And if we now analyze this script, we can see all the errors go away. And if we check this global, we can see that it has all the correct types to work. Now I'm going to create two local functions, one called world item added, and I'm going to create another one called world item removed. And then I'm going to wait for the start phase. And once we get into the start section, we're going to connect to this folder, child added and child removed events. So over here, I'm going to say global start. And just like we did for the player object, remember we first looped through all the players, because remember when we get to this start stage, we don't know if any items have already been replicated to the client. So over here, I'm going to first loop through the folder, and I'm going to use global spawn so we can do cache thread recycling. And then I'm going to connect the folder. And I'm also going to connect the child removed event. When an item streams to the client, we're going to do almost the same as we did here. First, we're going to create self. So I'm going to say local self equals global metatable world item, which is the same as we did on the server side. Then, unlike the server, we're not going to clone the item. We're just going to use the item that's streamed to the client. So I'm going to say self.instance equals instance. And then I'm going to add it to the collection the same way we did here. I'm going to say world item collection, insert instance self. And finally, over here, we can remove the item from the collection. Now we can get self from the remove like this. Now I'm not going to use this self, so if you really wanted to, you could remove this, but I'm just going to keep it there so we can see that it's possible to get the object over here. Now another very small optimization we can do is, instead of waiting for this folder over here, because we only use this folder down here, there's not really any point waiting for it up here, because we're just blocking the other scripts from entering the initialization stage. And also, if we placed it over here, it would block players from going into the start stage until this folder streamed in. So while it's okay to have the folder at the top, because this folder will stream in almost instantly, we can have a very small amount of performance benefit by adding the folder down here, and that's going to allow the other scripts to enter the initialize and finally enter the start stage without having to wait for this folder to stream in. So we've finished our client-sided world item, but just to get a bit fancy, let's add a tween on the item on the client side. So the first thing I'm going to do is get the tween service, and then I'm going to create a tween info. So over here, I think I'm going to do this above the collection. And once we've created the tween info, what I want to do is I'm going to store the tween inside of the world item object. We don't really need to do this, but I'm just going to do it so I can show you how it's done. So I'm going to create a type. It's going to be tween, and it's going to be a tween type. So now, after we've set the instance, I'm going to create a tween and store it within the object. So over here, I'm going to say self.tween equals tween service create, and I'm going to pass in the instance, the tween info that we created up here. I'm going to set the orientation to the instance's orientation plus 180 degrees. And because we've set the loop count to -1, it's going to keep looping round and round forever. And what I want to do is finally play the tween. So I'm going to say self.tween play. Now we could cancel the tween over here when the item is removed, but that should be done automatically, so we shouldn't need to cancel the tween. If we now play the game, we should see that the items spawn, but we get an error. It's saying that this collection value is nil. So why is that nil? So let me show you why. So remember when we copied these library scripts over to the client, these scripts are set to run context server. So because this is the client side now, we must change these library items to have a run context of client, so they run on the client side. So if we now play the game a second time, now we can see we don't get no errors, and we should see that when the items spawn in, we can now see that they tween round and round. Let's now make a character script that's going to detect when we touch a item and send an event to the server asking to pick the item up. Now, ideally, you would want to create a character object the same way we created a player object or the world item, but I'm going to cheat a little because I don't want this video to get too long. So I'm just going to create a very basic script to work as the character script. So I'm going to create a script. I'm going to name it character. I'm also going to make sure to set the run context to client, so it runs on the client side. And just like the other scripts, I'm going to make this script strict. And I'm also going to require the global. What I'm going to do now is create two functions, one called touched and another one called character added. And then I'm going to wait for the start stage. And once we're in the start stage, I'm going to check if the character already exists. If it does, I'm going to call the character added function. So I'm going to say game player local player dot character. Then I'm going to use spawn to spawn a new, to pass the character into the character added function. Then I'm going to connect a event. So I'm going to say game.players.localPlayer character added, connect character added. What I'm going to do is inside of the character added function, I'm going to wait for the root part. So I'm going to say local root part character wait for child humanoid root part, and then I'm going to connect this root part to this touch function. So I'm going to say root part.touch connect touched. And now inside of the touched event, I'm going to see if this instance is a world item. Now we have two ways we could do this. We could check the parent to make sure its parent is the items folder, or another way we could do it is we could use the collection. Remember, we have a collection here and we use the instance as the index. So what I can do is I can say local world item equals global world item instance, and we should have autocomplete. So you can see we get the instance and tween, but we don't really need to do that. All I'm going to do is just see if it's equal to nil. So if it's equal to nil, we know it's not a world item. What we want to do now is if it is a world item, we want to send a event to the server. Now, one way we could do this is inside of replicated storage, we could create a folder with a load of remote events inside of them and interact with the remote events directly. But inside of the library, we have some wrappers for remote events. So we have the server event and client event. These are essentially wrappers for remote events. We can see that all they do is when we call the function, it calls the same function inside of the remote event. When we connect parallel, it connects to the same connect parallel inside of the remote event. So if you don't really want to, you don't have to use these. The main benefit of using these is that we get type check-in because these support generics. So you can pass in which types we need to fire. So we can pass in which types we need to use when we fire this remote event so that you can make sure that your type check-in is correct. So if you don't care about type check-in, you don't need to use these, but if you do, you can use these. So this one goes for the client, the server event. So let's place this on the client side. And let's also make sure we enable the script. And this one goes on the server side. So let's put this on the server side and enable it. Let's now create a event. So it's very easy to use it with these wrappers. So all we need to do is say global server event, and we can use any name we want. I'm going to use pickup world item, and I'm going to fire this event, and I'm going to pass the instance that we want to pick up. Now, if we pass the world item, remember that this world item is not going to be the same table as the world item on the server side. So we could pass this world item table to the server, but it's going to be a waste of data because this world item is not the same world item that's on the server side. So just passing an instance is probably going to be the best way to reference the item that we want to pick up. Now that the client is sending us an event when they touch the item, let's now detect that event on the server side. So what I'm going to do is we could add this inside of the player object over here at the bottom, but I'm going to add it into a separate script just because I want to show you that it's possible. So I'm going to say add a script. I'm going to name the script player events, and this script is going to also be strict like all the others. So I'm going to copy and paste this. I'm also going to get global. So I'm going to copy and paste this. So we get the global table. And I think now all we need to do is we're going to use global to use the client event to connect to this pickup world item event. So all we need to do for that is say global client event pickup world item, and we're going to receive a function. Now we could connect this function directly when we create the remote event. It's also possible to connect to it after the case, but it's easier just to connect to it directly through the constructor. And then what we want to do is the player instance is going to be passed to us and the item instance is going to be passed to us. Now we're going to use the collection inside of the player object, this collection over here, to get the player object from the player instance. So over here, I'm going to say local player object equals global players. Remember, we used the players index, and we're going to pass the instance as the thing. So what we need to make sure is, remember that the collection is only added, the player is only added to the collection after their data store has loaded. So there is a possibility that this player object is equal to nil. So what I'm going to do over here is I'm going to say if player object is equal to nil, then return and do nothing. And now we should have autocomplete for the player object. So we can see everything over here is here. We have access to their data store with all their values. So everything is working correctly. Now what I want to do is I want to get the world item using this item instance. So I'm going to say local world item global world item, and I'm going to pass in the instance. And just like the player, if we look at world item, we can see we use the same index, and this should also have autocomplete. So if I say world item dot, we can see everything is here. Okay, now I'm going to make sure that this world item exists, because a exploiter may pass in a different type of instance, or maybe two players tried to collect the same item at the same time. So there's a possibility that this item may no longer be available. So what I'm going to do is say if world item is equal to nil, then return and don't allow them to pick up the item. The next thing you probably want to do is use a anti-hack to make sure that the player and the item are close to one another. Now, this framework doesn't currently have a built-in anti-hack, but I'm just going to add a to-do here. Use anti-hack to check if player is close to item. And then once we check the anti-hack to make sure they're close to one another, we're going to give them their coin. So all we need to do is say player object.data plus equals 1 for the coin. And I'm also going to update their leader stats. So I'm going to say player object coin value.value, and I'm going to set it to the same value that's inside of their data store. And finally, I want to call the destroy function for the world item, like so. And there we have our event completed. Another thing we want to make sure we do is we want to make sure we connect to this event in the start stage, because when we access players or world items, remember that this collection is created in the initialization stage. So we need to make sure we connect this event after the initialization stages have completed. So over here, I'm going to say global.start, and that's going to ensure that the initializations have finished and these collections have been created before we connect this event. If we now play the game, we should see that if we touch a coin, it should get destroyed and our coin value should increase. So let's wait for, now if I try to touch it now while my data store hasn't loaded, it's going to be rejected and the coin's going to stay. But if we wait a little longer for my data store to load, now if I touch it, we can see it gets destroyed and now I have 1 coin. And if I touch this, it gets destroyed and now I have a total of 3 coins. And when I stop the game, we should see that it says 3 for the coins when we save the data store. Everything seems to be working fine, but we still have one problem, and that is once we've collected a coin, the item spawner doesn't not restart the timer. So let's close all these scripts that we have open. And let's open the item spawner and the world item. Now there's a few ways we can go about doing this, but I'm going to store a item spawner inside of the world item object. Now this may or may not be set, so I'm going to use a question mark So what I'm going to do is say item spawner equals item spawner, and I'm going to add a question mark because maybe some items were not spawned via a spawner. We may have manually spawned the item through the function in a different way. Now the next thing I want to do is receive the item spawner over here for the function. So I'm going to say item spawner, and over here I'm going to say item spawner, which is a global item spawner type, but I'm going to add a question mark, meaning that we don't have to pass in a item spawner if we don't want to. Now the next thing I'm going to do is, once we've set up the instance, I'm going to say self.item spawner equals item spawner. So if we do pass in a item spawner, it gets set. If we pass in nil, then this will also be equal to nil. If we go back to our item spawner script, what I want to do is, after we go into the start stage, I want to connect to this collections removing event. So over here, I'm going to say global world items removed connect. So this is going to tell us when a item is removed from this collection, and it's going to tell us the index and value, the instance, which is a mesh part, and the world item. Then remember that not all items have item spawners. Some of them are spawned without item spawners. So we need to check to make sure it has a item spawner. So I'm going to say if world item spawner is equal to nil, then I'm just going to return and do nothing and ignore this item. But if this item does have an item spawner, I'm going to start the timer for this item spawner. So I'm going to say world item spawner, and we can see that Roblox is able to know which type it is, and we can also see we get autocomplete over here. So I'm going to use the timer, and then I'm going to use the start function like so. Now it says we want to pass in a duration. Now for the first time we used between 5 to 10 seconds, but for the second time I'm going to increase the time slightly, between 10 and 15 seconds. Final thing we need to remember to do is, when we create the item with the item spawner, we need to make sure we pass in the item spawner into this function so it gets set correctly. So over here I'm going to say self. If I now move this back over here and press play, once my data store loads, I should be able to collect some coins. And after 10 to 15 seconds, they should respawn. And once I collect them again, they should keep respawning over and over again. Let's add a NPC that allows us to trade coins for levels. Now, ideally, you would want to use something like the item spawners, where you have a folder inside of Workspace, and then you loop through the folder of NPCs and set up an object for each NPC. But I'm just going to do this a simple way, also to demonstrate that we can have scripts inside of our Workspace. So all I've done is I've created a rig, and it's a simple rig with just some parts, and inside of the head of the rig I've created a proximity prompt and a trade script which has a run context of server, so it only runs on the server side, and a face. So inside of script, all I'm doing is requiring game server script service global, which is this module over here. Then I'm waiting for all these scripts to initialize. Once they've initialized, we go into the start stage, and all I'm going to do here is connect to the proximity prompt. So to do this, I'm just going to say script parent proximity prompt triggered. Then I'm going to use the collection from the player object to find the player. If the player does not exist, that means their data store has not loaded or they're no longer in the game. And then I'm going to add the amount of coins to the level, set coins to 0, and I'm going to update their leader stats. And that's about it. So now if I play the game a final time, once my data store loads, if I try to do it now, it's not really going to do anything. If I try to collect coins, it's not going to work. And Once my data store loads, I can start collecting coins. I now have 2 coins. I go over here, press E, and I have 2 levels. I come over here, collect another coin, and I should have 3 levels. So we can see that even though this script is not inside of SourceCode service, we can still use scripts inside of Workspace. The framework and plugin for this framework are fully open source. And if you want to view or edit the source code, you can come to this place. There will be a link in the description of this video, and click on these 3 dots and click Edit in Studio. And once you've pressed the edit button, it should open this place. And inside of SourceCode service, you'll find the library of all the scripts that you can find on the toolbox. You'll also find the plugin for toggle block comments, which is a pretty simple plugin. And you'll also find the plugin for global types. Now the main script is the event script, and the job of this script is to detect when a script has changed. So here we can see that we text document did open, did change, and we use that to detect when we need to analyze a script. And once we want to analyze a script, the script is first passed into the lexer, and the job of the lexer is to convert the script into tokens. And another thing you'll notice is that this plugin uses itself to work. So we can see we also have a global module over here with the types set up, just like I showed you before. And we have comments, and we call the global function to create global properties. So the plugin uses itself to work, which is kind of cool. So once the script has gone through the lexer to turn into tokens, it's then used in the analyzer to analyze the tokens to work out which types you want and which need to be copied over to the module. And so once we analyze, the analyzer passes the types and modules to this object, which is called the TypeScript. So all these scripts are a TypeScript object, and we store the types inside of each one of these scripts. And then we have the type module, which is this module over here, and this is an object for the global module, and we use this object to update the module. Now, some of you guys may be wondering if this plugin will reduce the performance of Studio, and in short, no it won't, but just to show you, let's run some benchmarks. So if we go into the event script, and over here we can see when we analyze a script. So what I'm going to do is move this down like so. Then I'm going to say local clock equals OS clock. And then once we've analyzed, I'm going to say print, and then I'm going to get the current time. So OS clock negative clock. And I'm also going to pass in the script name so we know which script was analyzed. So script.name. And if we now save this as a local plugin, and if we now open a script, we should see that each script gets analyzed. So we can see that it took around 0.0006, 0.006, 0.006. Now, if we look at the lexer script, which is a very large script, so this should be one of the slowest scripts because it's 500 lines of code, plus the code is very compressed, so there's a lot of tokens. Here's a token, that's another token, that's another token, that's another token, another token, another token. And if we find the lexer, we can see that even this very large script took 0.006 seconds to analyze. And it only analyzes all the scripts when you first open Studio or when you first install the plugin. So once all the scripts have been analyzed, it won't keep analyzing all of the scripts all the time. So if I come over here and make a change, we can see it only updates the lexer script. And if I change this script, we can see it only updates the script. Now, if you keep typing, it doesn't keep analyzing after every character. It only analyzes after a 0.4 second delay. And let's also measure how long it takes to update the global module. So analyzing and updating the module are done in two separate stages. So here we can see we analyze and then we batch update the modules once all the analyzes have completed. So if we go back to type module and scroll down, we should see over here when we loop through the modules that need to be analyzed, and we start the analyze over here. So let's make local clock equals OS clock, and then over here I'm going to say print. Actually, let's use a warning so it's more defined, and I'm going to use the self.modulescript.name, and I'm going to print OS clock negative clock. Okay, so now what we should see is if I save this as a local plugin, and if we open a script or make a change, we can see that it analyzes all the scripts, and once it's finished analyzing, it then updates the modules just once. And we can see that updating the modules is also very fast. It takes around 0.005 seconds. Now, one thing to take note is if you have the module open and keep the module open when you make a change, it's going to be a little bit slower. So if I make a change to the type, so let's change this to type module A, we can see it took a bit slower. But if I close the module and make a change, we can see it's a lot faster. And this is out of my control. This happens because if the module is open, I believe that anytime we make a change, Roblox has to reanalyze this script. Another thing to take note is the module is only updated when we edit the type information or if we edit the globals. So if I make a change over here, we can see it analyzes the script, but it never updated the global. But if I made a change over here, then it will analyze the script and update the global. So global is only updated when it's only necessary. There we have it. So that's everything I need to say about this framework. So if you have any questions or if you run into any problems, please join the Discord server. The link will be in the description, and please share any bugs or any problems that you experience, and I'll do the best to try and help you.